Hello students, welcome to chapter 13, limits in derivative. Students, in derivative, today I continue example 23. Before start 23, I just request to you just write down formula at least 2 to 3 times. In 1 to 15 all formulas. Then after start this video. Now example 23, sin x plus cos x derivative find out by the first principle. First principle you know that, and you just apply f of x plus h. You will show that in the sin x plus h plus cos x plus h, and apply the first principle, functions f plus x, limit h tends to 0, f of x plus h minus fx upon h, and apply that both values. So students, my answer is limit h tends to 0, here sin x plus h, cos x plus h, minus fx, apply this fx, a sin x minus cos x, below h as it is. Now this I arrange to that, and this I arrange to that, simple taking. So limit h tends to 0, in the first data sin x plus h minus sin x, same cos x plus h minus cos x, and upon as usual. Now formula you know, sin minus sin and cos minus cos. Students, if you direct operate this answer, then sin derivative minus cos, sin derivative cos, and cos derivative minus sin. So your answer is that cos minus sin. But I go to here definition wise, first principle wise. So limit, here formula s minus s, 2 cos sin, both added by 2 angles, and here both subtraction angle by 2. Same students, here operate now c minus c, which is minus 2ss. Same applying both angle dividing by 2 students. So both you added x plus h plus x and x plus h minus x, and upon h we will write down as it is. So if you have to know, simple, limit h tends to 0, here remaining data 2 cos, here remaining are 2x plus h by 2, with sin this cancel x and x, I have only sin h by 2, and next minus 2, here sin 2x plus h by 2, 2x plus h by 2, and another r, this cancel, only I have sin h by 2, and upon also same to h. So it is here you will take the common 2 sin h by 2 in the both functions, one of the that. So limit h tends to 0, 2 into sin h by 2 common, but remaining you have to cos 2x plus h by 2, and here also sin 2x plus h by 2, and upon h is as it is. Now students, these two divide by that and arrange for that, it is indirectly 1. So limit h by 2 tends to 0, sin h by 2 upon h by 2, and another r, limit h tends to 0, here cos 2x plus h by 2 minus sin 2x plus h by 2, that one, and internally function put it, here it is 1, and that is cos of 2x plus 0 by 2 and sin of 2x plus 0 by 2. Indirectly students, your answer is done here. Here answer is a cos x minus sin x, and that's the students, you easily get simple in this form of This answer for direct also you will judge. Sine derivative is cos and cos derivative is a minus sine. Now after ending students, we going ahead second one. Also find the derivative by the first principle. And question is that x into sine x. Second questions in the 24th real example, x into sine x. Second one, x with sine x. And find the first derivative by the simple formula. So I will go to f of x plus h. Here x plus h and sine with x plus h. So this is a IMP numerical to board related, final exam related. So by definition, your f dash x is a rule you had known, limit h tends to 0, f of x plus h minus fx by h. The same, and you putting down the value for x plus h with the sine x plus h minus x into sine x and upon h as it is. Here I will show the multiplications. So limit h tends to 0, x with sine x plus h plus h with sine x plus h and minus x sine x and upon h you will show the as it is. Now here look students, this part and this part I will take just only common, and after that you will decide the further property using to your trigonometric parts. It's very easy. So here I will show that this part and this part in common forming. So limit h tends to 0, x common first and the last. Remaining I have sine x plus h minus sine x and another same h sine x plus h upon h here do, one of the here do, and that's the cancel. Apply sine minus sine. So limit h tends to 0, x and this property sine minus sine 2 cos sine. Yes, we will go that 2 cos sine. Both angle divided by 2 sure. Addition form. So x plus h plus x plus h minus x, and here limit are separate taking. Limit h tends to 0. Here only sine with x plus h by only 1. Now this also cancel, x and x. So you have to only upon h pending here students. By mistake I forgot that. Limit h tends to 0, 2 cos 2x plus h by 2 and remaining sine h by 2 upon h same is plus here apply sine x plus 0 by the working rule. Here finally students this 2 divide with h and collect from that with sine h by 2, it is 1. So limit h by 2 tends to 0, sine h by 2 by h by 2, and another is same, limit h tends to 0, cos 2x plus h by 2, and that is the only sine x. Now easily that is the one that apply the rule. So it is 1, x is pending students. So here x into, it is 1 x, here cos 2x plus 0 by 2 and plus sine x as it is. Now 2 to cancel, your answer is x into cos x plus sine x. That's the final answer. And last answer for x sine x. Now I continue students our example, going ahead, continue to 24. Find its derivative only. not using the first principle, it means we go to simple working rule. Working rule wise, we will derive that 24 the two questions d dx of. My question is that sine 2x. Very easy. Just we will show that 2 into sine x into cos x. To make separate, and other apply your product rule, that is the u b. To make separate, first second derivative plus second first derivative. Just I will operate to basic working rule to product rule, and now all both formula you known. So 2 same sin x, cos derivative is a sin x but minus, and here cos x, it is a cos x sin derivative. So you have to know minus sin square x plus cos square x. Just I rearrange cos square minus sin square, and that is should be known the formula, which is cos 2x. Either this answer also correct and second answer also correct. Now continue second one. By working rule, use the and derive the formula by d dx of. Our question is a simple cot x. So cot, I just known cot x derivative minus cos x square x, but I will derive by division rule cos below sine and use the your formula to cos by sine, means sin square x denominator square. All of you know that simple way. Now denominator d dx of numerator minus numerator d dx of denominator, and use the formula. So your answer is sin x same cos derivative minus sin x. Continue. Now cos derivative, now sin derivative. Sin derivative, students, only cos x, and my answer is sin square x as much as same minus common. So sin square x plus cos square x by sin square x. But that is you know, it is purely 1. So minus 1 by sin square x, and which is the minus cos x square x. That's why cot x derivative is a minus cos x square x. Now continue example 25, students, which is also IMP for exam. Example 25, the first one, find the derivative of the given two functions are there in the mixing form given. One of the x raised to 5 cos x, x raised to 5 minus cos x divided by sin x. Again repeat the question, x raised to 5 minus cos x by sin x. Yes. So students, here just apply our division rule. So in denominator square sin square x. Now denominator d dx of numerator minus numerator d dx of denominator. This is a main step. Whenever you apply division form, this step you compulsory write down. To denominator square, denominator numerator derivative minus numerator denominator derivative. Now according to formula, you will submit the answer. Here x raised to n related 5 x raised to 4 cos derivative minus sin x. Next, here also same, sin derivative is a cos x, and upon as much as same as. So sin, just you multiply inside sin x with 5x raised to 4 minus minus plus. Sine to sine, sine square x. Same here, x raised to 5 cos x plus y plus this minus minus and cos multiply inside, here this sine multiply inside, upon sine square x. Actually students, this and that both you know, it is the one only. So here sine x with 5x raised to 4, that and that is 1, minus x raised to 5 cos x, 1 below sine square x. Again I repeat, this one actually coming from here, sine square x plus cos square x is equal to 1. Now we same going question second, ddx of 25th example, question number second, x plus cos x below tan x. Again check, x plus cos x below tan x. Same apply, u by v rule. In the division form, we will start denominator square and another denominator ddx of numerator minus, now numerator ddx of denominator. That's your simple apply the formula, denominator numerator derivative and numerator denominator derivative. My answer is done. X derivative is 1, but cos x derivative to minus sin x, this much same is. Now students, tan derivative, you also know that it is a sec square x, and upon also same as 2 tan square x, and that much as over that our miscellaneous example 25. Now students, I will start to miscellaneous exercise 13. Yes, exercise 13th one, to first question, solve by derivative fx is equal to minus x by the definitions. Find derivative by definition. So very easy, x derivative known you 1, your answer is minus 1, but I will go to by the definitions, f of x plus h minus x plus h, and by definition f dash x limit h tends to 0, f of x plus h minus fx by h, and put down the values one by one according to you derive. So indirectly my answer is simple way coming here, limit f dash x functions limit h tends to 0. What is f of x plus h? Minus x minus h, and here minus of minus x. So your answer is limit h tends to 0, it is plus x by h. Cutting only you have limit h tends to 0, h cancel, and your answer is simple minus 1. Now second, same as there are the 4 questions. Question 1, second one, minus x raised to minus 1, minus x raised to minus 1. Very easy, I just arrange 1 below minus x indirectly, which is minus 1 by x. Now I will continue to simple our derivative formula for basic definitions. It is x plus, you will write down x plus h, and by definition f dash x limit h tends to 0, f of x plus h minus fx by h. So your answer is coming there, f of x plus h minus 1 by x plus h, minus fx means this one, plus 1 by x, and upon h as it is. Now we will take to LCM and try to simplify till up to this h. Yes, students, try to simplify this h anyhow removing. So limit h tends to 0. Here take LCM, minus x plus h into, here same is 1 by h. Now this cancel, only h remaining. So limit h tends to 0. Other you have to h upon x plus h into x 1 by h. This much also cancel. And now students, put down your value 1 below x plus 0 into x. It is 1 by x square. You also know directly 1 upon x derivative, minus 1 by x square, and minus it is plus 1 by x square. Now third, fx is given that which is sine x plus 1. So does direct answer if you operate then cos x plus 1. Sine derivative is cos, and x derivative 1 and 1 is 0. So your answer is cos x plus 1. But I will go to by definition sine x plus h plus 1, and I just operate by the rule of definitions. Limit h tends to 0, f of x plus h minus fx by h, and just apply by the formula value put it. So limit h tends to 0, that's the sine x plus h plus 1 minus sine x plus 1 by h. And now students, reading that sine minus sine, which is 2 cos sine. So limit h tends to 0, 2 cos sine by h, that one. Both added by 2, and both subtract angle by 2. So your answer is, students, here x cancel, 1 cancel. Another, as it is, I will show that in my solutions. So you will create your answers in the parts of limit h tends to 0, 2 into cos, here x and x to x plus h plus 2, 1 and 1 2 by 2, and remaining I have to sine, 1 1 cancel, h just cancel, h by 2, and upon h same is. So does this 2 divide by that and arrange with this form. It is sin h by 2 and h by 2 1. So you have to only limit h by 2 tends to 0, sin h by 2 by h by 2, and remaining limit h tends to 0, cos with 2x plus h plus 2 by 2, and easily you get the answer because it is 1 only. And here cos of 2x plus 0 plus 2 by 2. In short, I will telling that 2 to cancel, only x plus 1. That's my answer for derivative of sin x plus 1, which is cos x plus 1. Direct answer. And also definition wise I will complete here. Now fourth, it is IMP. fx given and question is there, cos of x minus pi by 8. X minus pi by 8. One more time repeat, cos of x minus pi by 8. Your answer is minus sine x minus pi by 8. But I will go to definitions. F of x plus h, cos of x plus h minus pi by 8. So by definition, f dash x, limit h tends to 0, f of x plus h minus fx by h, and apply that 1 by 1 your systematic values. So you will get in the form of easily answer. So f dash x as it is, limit h tends to 0. Here f of x plus h, cos of x plus h minus pi by 8. This your f of x plus h minus cos of x minus pi by 8 and upon h as it is. Students, here reading successfully cos minus 2ss. So limit h tends to 0 and the value of line minus 2 sine both angle dividing by 2 and upon h as it is, and just you take both additions, x plus h minus pi by 8 plus x minus pi by 8, and both subtraction minus x plus pi by 8. So you have to simple clearly, students, this cancel and that cancel, and here limit h tends to 0 minus sine with the sine. These are same as x and x 2x plus h 2 times pi by 8 by 2, and this value are remaining to sine only h by 2 upon h. So does here you know this 2, if I divided with h, collect from them, it is indirectly 1. So minus outside, limit h by 2 tends to 0, sine h by 2 upon h by 2. That's the first value. And secondly, limit h tends to 0, sine 2x plus h minus this cancel, pi by 4 by 2. One more time repeat, here pi by 4 and another are same as. Students, these functions you know it is exactly 1. So minus 1 into 1. And here sine, putting your limits in place of h, putting value 0. So here 2x plus 0 minus pi by 4 by 2. So your answer is minus 1 into sine. 2x by 2 means x, pi by 2 means pi by 8. That's your answer, students. If you direct operate, then also coming answer. Just like your question is what? Cos. Cos derivative is a minus sign and function as it is. X derivative 1 and pi by 8 derivative, students, 0. Students, here our exercise 13, question 1, all 4 questions happily and easily students done. Students, after that ending these questions, I will stop this video, and further explanations for exercise 13 question number next second I will explain you in the next parts. Bye bye, see you.